Okay, so this is the lesson for the purple group for lesson 79. One of the things that's a little bit different is at the end of each section, when you pause and you're going to be working the problems, before you move on to the next section, I've added in this thing that's going to ask questions before you can move on to the next section. So once you have them all done and you unpause the video, there's going to be a question that pops up just for you to check one or two of your answers. And so enter the answers in there before you move on to the next section. And then when you're done, I'll be able to check your score on my computer and we'll see if there's any parts that we need to go back and make corrections on. Okay, so if you have any questions when those checkpoint questions come up, just make sure to come and ask a teacher. Okay, so to start out for 79, we'll do part 1 in the textbook. So I'll read what it says in the box and you can follow along. So it says, if the fraction part of a mixed number equals 1, you can write the mixed number as a whole number, you just add 1. So right here you can see I have 3 as the whole number, and then the fraction part is 14 over 14, so I know that this 14 over 14 is another 1. So if the fraction equals 1, what it's really saying is 3 plus another 1. So 3 plus 1, so 3 plus this fraction that equals 1 means that I have 4 wholes. So another mixed number is 19, and then the fraction part equals 1, 7/7. So it's easier to say, instead of 19 plus 1, I could just say 20. So go ahead and go to part 2 and we'll work on some problems. So here's part 2 in your textbook. So all of these are mixed numbers. If we look at A, we see that we have 8 and 5/5. And since I know that 5/5 is equal to 1, I know that really what's here is 8 and 1. So that means that really I could just write this as the number 9. So what you're going to do is you're going to go through each of these and you're going to rewrite them only if the fraction equals 1. If the fraction after it does not equal 1, then I cannot rewrite it. I could not write this one as 10 because here I've got 9, but then this one's a little bit less than 1. So really I would have 9 plus a little bit extra, but not enough to make 10. So I can't do B, so I'll skip that one. Then I'm going to look at C, and I'm going to decide if that fraction equals 1, then yes, I can rewrite that one as just a whole number. I don't even need the fraction part. So go ahead and pause the video. You're going to work only the ones that have the fractions that equal 1. If they don't have a fraction that equals 1, skip it. And then once you are done with this section and you unpause the video, answer the questions that pop up for you. Okay, so for part 3, we're doing rounding, but instead of underlining the place value for you, they've just told you what it is. So if I was going to work A, instead of underlining it for us, they tell us that we have to round it to the nearest million. So what I'm going to do is I'll actually rewrite this a little bit larger right here. And I have to find the millions place. So I know that if I start here, this is ones, tens, hundreds, thousands, 10,000s, 100,000s. This is the millions place. So you can underline it here if that makes it easier to keep track. So I underline the millions place. That's the one that I have to make the decision about. So that means from here is where I look next door. And I have to decide if this is 5 or above, then this would go up. Or if it's not 5 or above, then this would stay the same. So when I look next door, I see that I have 2. And 2 is not 5 or above, which means that my millions place is going to stay the same. So when I rewrite it, the number before the underline always stays the same. Now we've already made the decision about the underlined one. Since this was not 5 or above, this underlined one gets to stay the same. and then everything after the underline changes to zeros. So when I've rounded this number, I know that 17,298,608, when rounded to the nearest million, it would be 17 million. So go ahead and work each of the problems in this section, and then when you come back, answer the questions that are on the screen. For part 4, I'll read what it says in the box and you can follow along. So it says that we've already used the equation area is base times height. So we've done that for rectangles. So area of a rectangle is base times height. And you can use the same equation to find an area of a parallelogram. So we can see here that a parallelogram has 4 sides. It kind of looks like a rectangle that's been knocked to the side a little bit. So even though the lines on the sides are not straight up and down, they're still parallel. Parallel means that if I was to extend this out, these 2 lines would never touch each other. They could go on forever in these directions. They would never touch each other. The same way for the up and down. If I was to make these long, and they would go on forever and ever and ever, they're never going to touch each other. They stay the same distance apart. So that's what a parallel line is. And so when I make parallel lines on top and bottom, and also on side to side, we call those parallelograms. So all of these right here are parallelograms. So we can use the equation area of a rectangle to find the area of any of these figures. So the equation works with parallelograms because parallelogram has the same area as a rectangle that would have the same base and height, which means that even though this one is tilted to the side a little bit, you can see here that even though this one's tilted to the side, it takes up the same area. Area is how many little squares can fit inside the shape. So there are just as many squares fitting inside this like tilted parallelogram as there are with this rectangle that's straight up and down. So these would have the same area, which means that we can use the same formula, area equals base times height. So you have to remember that the height of a parallelogram on the coordinate system is always a line that is parallel to the y-axis. So what that means is when we're trying to find the height of a rectangle here, we just use the same one that's parallel to the y-axis, which means that this one goes straight up and down and the y-axis goes straight up and down. So when we're trying to find the height of a parallelogram, we have to use how high it goes to this straight line here. I can't use this slanted motion because this one, if you see, is not parallel to the y-axis because you see that those lines cross here. So that means that this is not the one that's parallel because they eventually touch each other. And remember, parallel lines can't ever touch each other. So if we're trying to find it for this one, I have to use this one as straight up and down because that's what's parallel to the y-axis. So whenever you're trying to find the height, you have to go kind of to this inside corner here and just go straight up and down the y-axis to see how high that it goes. So always remember to use this inside line to do the straight up and down to see that it would go up 1, 2, 3 squares. Okay, so that's what you have to remember. Same equation, area equals base times height. So go ahead and flip to part 5. All right, so we look at part 5, we see that we have parallelograms here, and we're going to find the area. Remember that we're using area equals base times height. So that's my formula here, area equals base times height, just like I would do for a rectangle. So first, what I'm going to do is I'm going to find the base. So the base is the bottom. So what I'm going to do is I'm going to look down here and decide how long this line goes to this. So it starts at 0, and I know that it comes across to 7, so my base is 7. It goes across 7 squares. what I'm looking for when I do the height is I have to go to this line. So what I'm going to do is when I do the height, I'm going to look at the top line, and I'm going to go to a corner, and I'm going to take that corner, and I'm just going to go look how high it goes. So starting here, I look here, it goes as high as 5. That's how high it is. Remember, I'm not using the slanted one. I have to use this corner and go straight down, and I can see that the height, how high it goes, is number 5. So 7 times 5, which means that then my area is going to equal 35 square, always use the units, and I can see here M, which is meters. So for A, I've done the base 7, and I see that my top corner goes to 5, so that means that I'm going to do 7 times 5 is 35 square meters. All right, the other type of problem before you get started is I wanted to show you that on B, when I'm trying to figure out the base, here when we were doing A, it was easy because it started at 0 and went all the way to 7. But here, you can see that our base doesn't start at 0. Our base starts at 3. So I can't look here and say that my base goes from 0 to 9 because it's not that long. It doesn't go from this corner all the way over here. So when I'm trying to figure out the base, I have to start at 3, and I can either just count over, so 1, 2, 3, 4, 5, 6, so I know that my base would be 6, or I can just look at 9 minus 3, and I would know that I would get 6. So if it's easiest for you to count, that's fine. So 1, 2, 3, 4, 5, 6. So that means that my base here is 6. And then when I'm trying to find my height, I'm going to go to my top line here to see how high I am. Make sure it goes straight up and down, and it goes as high as 4. So for B, you're going to figure out 6 times 4, and when you get the answer, make sure to use the square inches, because this is showing us that it's inches. So go ahead and solve the rest of the way for B, and then also do C and D. So pause the video, and when you come back, answer the questions that are on the screen. So starting on part 6, says, let's read the directions first. It says for each item to make a number family with 3 letters and then work the problem. So you're going to start out making your number family, and we have to figure out first, because when we read the first sentence here, it says that angle H is 7/10 of a circle, which means that first I have to figure out a number for angle H before I can plug the numbers into the number family. So when we say 7/10, when I have 7/10, and then I see the word of, I know that of means multiplication. And for circle, we remember that circle is 360 degrees. So I'm going to solve this problem before I put it into the number family. So in multiplying fractions, I have to put my hidden number 1 over here. And so when I work the multiplication problem straight across the top, I'm going to do 7 times 360, what will get me, which is 2,520, 2,520. And straight across the bottom, 10 times 1 equals 10. So I can't leave it like this as a fraction because I'm trying to get it into a whole number, so I'm going to have to divide. So I'll take 2,520 divided by 10, and my answer for that, for what's going to be angle H, will be 252. So let's look back here, and I'm going to decide which is my big number and which are my 2 small numbers. So I can see here that H goes all the way around here. So I know that H is the biggest part, so H is going to be my big number, and M and G will be my small numbers. So now that we've figured out together how much H is, and they've tell you angle G, So I want you to start here and plug your numbers into the number family and figure out what to get for angle M. So finish up A and then also work B and C. So pause the video and then come back when you are ready to answer the questions. So before you start part 7, I want you to look at your textbook. Look inside the back cover of your textbook. So flip all the way to the back and then look at what's printed inside the back cover. And what's in there is a list of abbreviations of units. So what that means is that the short way of writing things that we use to measure or weigh things. So instead of using pounds, you can see that pounds you could use LB. Or for ounces, you could use OZ. So if you see in the problems that we're going to work, like ounces or grams, instead of writing out the whole word, what you can use is go to the back of the textbook and find what the abbreviation is, and then use that instead. So remember that that's back there, and then once you're done taking a look at it, come back to part 7 on page 264. And what you'll see here is that some of these are ratio problems. And remember that if the problem tells about more than one, but is asking about one thing, then we have to write an equation that tells what the one thing equals. If the problem tells us about more than one, but it's not asking about one, it's asking about a different number other than one, then you have to work a ratio problem. So looking at A, they're asking about more than one, right? In the question, this is what they're asking. They're asking about more than one, so this one I'm going to set up just as a regular ratio equation, right? We're comparing boots to ounces, so like boots to ounces, number times a number equals a number, right? That's the ratio because I can see here that they're asking about more than one. So for B, they're asking about 1, which means that I'm going to have to try to figure out how much 1 marble weighs. So since they're asking about 1 in the question, that means that I can't set it up as a ratio. I have to do the division problem where if I know that 12 marbles equals 42 grams, and I know that my abbreviation is grams, I need to figure out how much 1 marble weighs. So which means that instead of having 12 on this side of the equation, I need to figure out how to make it into 1 because that's what is in the answer is asking for. So in order to get it down to 1, if I divide by 12, because I know that 12 divided by 12 equals 1, so that'll take care of this side because now I know that I'm just going to have 1 marble on this side. But in order to keep an equation balanced, whatever I do to one side, I have to do to the other side. So that means that 1 marble is going to weigh 42/12 of a gram. But in order to simplify that, so instead of giving my answer like this as a fraction, I can put it in my calculator and do a division and do 42 divided by 12. And what I will figure out is that 1 marble is equal to 3.5 grams. There you go. So ask yourself before which type of problem you need to solve before setting it up. If they're asking about more than 1, then you set up a ratio. If they're asking about 1, that means that you have to do the division in order to get one thing by itself. So go ahead and go back and do A, finish plugging in the numbers for that, and then also solve C and D. And when you're ready, come back, check your answers with the questions. Okay, so for part 8, what they're telling us to do is that we have to make a fraction number family, right? That's in the directions, fraction number family, because each of these sentences compare two things. So first we have to figure out which one is the big number and which one is the small number. So if we're reading A, it says that Ronald runs 7/8 as far as Ginger. So Ronald runs 7/8. We know that 7/8 is less than 1. And since it's less than 1, that means that Ronald will be the small number and Ginger will be the big number. And what we're looking for is the difference between how far they ran. So we know that Ronald is 7/8, which means that I know the bottom number has to be the same. And since we're comparing Ronald to how far Ginger ran, Ginger's going to be the number 1. Remember, one of these two always has to be number 1. 8/8 is going to be 1 because they already told us Ronald was 7/8. So I'll do my subtraction. I know that the bottom number will always be 8 because it's what it is straight across in my fraction number family. And then I do the subtraction. 8 minus 7 is 1. So we know that he ran 1/8 as the difference between how much he ran and she ran is 1/8. So what I'll do is I'm going to go ahead and read the problems out loud. So you can listen to me read the problem and then pause it to solve it, or you can just pause it, solve it, and then come back to answer the questions that pop up on the screen. If you need to hear it read more than once, just rewind the video. So here's B. Today's temperature is 8/5 of yesterday's temperature. Again, for B, it says today's temperature is 8/5 of yesterday's temperature. Remember, if you want to solve it, go ahead and pause it, and then here's C. The tower is 13/10 as high as the apartment building. The tower is 13/10 as high as the apartment building. And here is D. Factory B produced 3/8 of the amount that factory C produced. Here it is again. Factory B produced 3/8 of the amount that factory C produced. So when you are finished with this section, come back and answer the questions that'll come up on the screen. This is the end of the lesson. So once you have finished this section and answered the questions, check in with a teacher so they can check your score of how you did on all of the questions. And we'll see if there's any corrections we have to go back and make before we start our independent work.